I really hate these eco-friendly hard drives that always spin down when I'm trying to. So pro tip, if you have a hard drive that likes to spin down all the time on you, those energy saving hard drives, which are really annoying, right? Because like every time you access the hard drive, it takes forever because it always has to spin back up. What I do is I write like a little bash script that just writes to a file every few seconds, just to make sure that the hard drive is always spinning. So I got this little bash script, and I just always keep this bash script running all the time when I'm logged into my computer, to avoid the hard drive from spinning down. It's annoying that I have to have a hack like that, but also, interestingly, I read about this, and having a hard drive always spin down on you and always having to re-spin it back up all day long, that's not healthy on your hard drive. That's going to wear your hard drive down and make it not last as long. And the irony of all this is it's a RAID drive. It's like a drive that's supposed to be protecting my data, and here it is just spinning down all the time. Yeah, just if you want to talk about micro optimizations, hard drive spin down seems like a pretty big micro optimization on the problems that this world has with saving the environment. But that's just my opinion. Okay, so we're going to get back to solving the formula for figuring out the border of the tiles that we're mapping. Right here, this formula. But so we have this variable, right? We're not going to use this crazy long variable. Width of a single tile measured in destination viewport pixels. God, it even goes over my column limit. I can't. In viewport pixels. So really what we want is size of tile measured in destination, measured in size of pixel, size of tile 1, it's measured in pixels, as seen in destination, and the destination is VP0 viewport. And okay, yeah, so we could do that, and that's gonna take rec VP0 like that. And so now we need a variable that means that. So it's gonna be it was gonna be God, what was it gonna be? Let me check my notes. So I know it was like tile and then P for pixels, right? Tile size pixels, yeah. So I loaded stuff, so let's see if I can do this. So it was tile size pixels, and it's the destination viewport, so TP0, and then width. Okay, there we go. So that is the correct name. And we have one for width and height. So var TP0 and then height. So what is the size of each tile as it will appear in our destination viewport? Well, it's going to be the size of the viewport divided by the number of sections, right? These number of sections that we calculated earlier. So let's see, did I have that correct? VP1 minus VP1, okay. Yeah, the number of sections, right? Because the number of sections is also the number of tiles, but so, 1 2 number of, I'm gonna change this a bit. So nx is, so nx and ny equals the number of, and one thing it equals is the number of sections on destination viewport, and it equals the number of tiles on source viewport, right? And so these viewports are VP. So the destination is a VP0, and the source is VP1, and we can just call them rectangle for now, just so that's easier to see the similarities in the code. Like when we highlight these, when we double click them, I'm going to call it, do that in the comment. Okay, so nx and ny is either the number of sections in the destination viewport, this, or the number of tiles on the source. So here's our viewport that's been zoomed into one single tile in this example problem. And over here, we need to figure out the tile size on the destination viewport. So we will take the viewport size, and we're just going to divide by the number of tiles on the x-axis, and then the same thing over here. We're going to take the destination viewport size, the height axis, and we will divide by the number of tiles on the y. So now we have the size of a single tile, and we can use that to kind of figure out what tile the dx and the dy value is currently in. And there's a lot of stuff here. So local coordinates of current tile in focus. So that's kind of what we're calculating right now. I got a lot of notes here. I'm just gonna take, I'm gonna cut out these notes here, and I'm just gonna paste them down here, because right now they are clutter. They're confusing me because it was a while since I was in this code, like a few hours ago. And I'm going to just calculate, it looks like current tile in focus, so tile x, tile y, that's the next thing I want to calculate. So if we go over here, we know that tile x is going to be this dx coordinate, which is the pixel on the viewport, and it's divided by the size of a single tile as seen on the viewport. So TP0 right here, these guys right here. So, okay. Now we're not taking into account the translation of the viewports, right? Because I'm just trying to solve this simply, and then we can figure out the adjustments that need to be done for the translation of the viewport after we've calculated the basics, right? So tile x, tile y. So, and then we can take this destination pixels tile value. Okay, I'm gonna take these this note right here, and I can put that comment above here as well. So current tile in focus, and also we're indented a little bit deeper, so AKA. Okay, or we might want to reverse that. God, I'm so OCD sometimes. So do that, and then we can say AKA like that. Okay, that's good enough. And then if we, continuing with my OCD, line that up like that. Okay, so tile X and tile Y. So now we know which tile we're currently rendering. And we kind of already had that information in our other formula. So maybe we want to take a look at that. So over here, dx, so where are we using dx? So source x and source y. So this actually This formula already tells us. God, that is complicated. Like, why is that so? Okay, so this is kind of like a one-liner. So this source x, source y is the this is the same thing as the tile x and tile y in the other formula, I think, that I was doing. Because source x and source y, right? Well, it's the source x and y here, right? Which is also the tile values, right? The tile values are on the source, and then we're going to sample from the source and go over here to the destination. So this tx, ty is actually, we can put a little note here, so that's easier to transcribe later. It's aka sx source x, right? So just a little note there so that when we are trying to plug all of this work into the main code, we know what the hell it stands for. And we can also put that note there as well. And we're running out of space, so we can do something like this. So just a little note to let us know that these variables also could be this, like they are synonymous. Before I continue any further, I want to save all of this and run it, or have some type of way where I can just make sure that I have some type of way to put this in a debugger and check my math. Basically, that's kind of why I've been solving this problem as code, so that I can run it in isolation and see if all my work kind of checks out. So what we're going to do is JavaScript HTML rig. We're just going to get a little snippet here for another HTML page, and we're going to plug in the file path to this JavaScript file. It'll need to be a script here in the head. So new UTF-8 script. Can I do that? Okay, so like that. And then we'll put the file path right here into... Then we can get rid of the... we don't need the absolute path. We can just take the file name, right? And it's going to be // for the current directory /math.js, because that's the script we want to run. I don't really need any of... There's a lot of clutter here. This is one of my older snippets, it looks like. Do I need this char set? So the char set I probably only need here. Well, if I have any type of Unicode directly inlined here, then I would need it. But we don't really need any code here. Well, do we? I don't know. Let me just clean this up a bit. So I'm just going to section this off. So I have a nice little area where I can start writing code, code here. What else? Okay, so that looks good enough. We can also... Title I would like to put here if we have some type of title. Math.js, I guess. And, okay, so we're about ready. I don't know. Now I'm just being picky. So we're gonna try to run the code and see what happens. So I'll math.htm. Okay, full file path to clipboard. We're gonna look at our top monitor here. We're going to paste that in there, and I don't expect to see anything. I'm gonna move this window over to the side, and then we're just going to hit F12 to open up a debugger, and we're going to put that on the right side, or the right partition of my screen. And let's refresh. I don't see anything going on. Okay, so this is just where I'm going to be looking at things to make sure my math kind of like checks out. I'm not quite ready to do that, but I just wanted to get that set up and out of the way for when I do. And we're going to continue solving this formula here. One thought I have is, since tx and sx should eventually be the exact same value, that we could just keep on solving for tx, and we could just not touch this, and put the tx variable like right down here somewhere. So we could solve for var tx, and then do whatever formula we have in the math.js that we're working on, and then we will do something like this. We'll just have some type of assert where we assert that sx equals tx, because they should both end up getting the same value. So rather than wasting the extra work we're doing, we can use that extra work to kind of like double check our work, right? So we're going to solve the equation in two different ways, and then rather than being like, oh man, I solved it in two different ways, I wasted all this time, you can add that as a redundancy to kind of add some error checking to your code, right? Now, if this were like C code, you could have that redundancy only when you're in debug mode, and then in release mode, you don't calculate the redundant variable, and you don't do any assert statements. I'm not really worried about optimization right now, though. We can afford to calculate this other variable and do some double checking. Save that optimization for later. Don't worry about it's better that we waste some cycles with some error checking than to optimize, to over-optimize, right? Over-optimization, premature optimization, that's already a bad thing. So don't not error check for the sake of over-optimization. Basically, you're gonna not do a good thing to go off and do a bad thing. Like, that's complete nonsense. Okay. So I'll be right back, and we'll continue kind of like solving this.